This is John Black, Super Chemist. This is my last chromium chemistry video, and it's to complete the cycle. In other words, how to recycle it after you use it. When you use potassium dichromate, it oxidizes something, but it in return gets reduced, okay? And it will get reduced from a +6 to a +3. I want you to recall back to my video on how to make chromium hydroxide. If you didn't see it, you should probably watch it. Basically, I had some chromium chloride, um, and all I did was I put it in solution. It's a salt, it's soluble. And then I put sodium hydroxide in solution and I mixed them together. Everything is soluble. But when the chromium and the hydroxide ions meet each other, they're insoluble, chromium hydroxide, and it precipitates out, okay? Now all you got to do, since it's a solid and your byproduct is sodium chloride, let all of the insoluble precip, the chromium hydroxide, settle to the bottom. Then siphon out the water, throw some new water in there that's nice and clean, soak up some more sodium chloride, siphon it out, throw some more clean water in there, and do that about 5 or 6 times until you have a very clean chromium hydroxide product. The reason why you don't just filter it and pour water over it and filter it, it will clog up your filter instantaneously within a second. You will be filtering for years. So that is not a viable, it's a terrible way to do it. So when we did that, we had a chromium 3 salt, chromium chloride, and we made a chromium 3 hydroxide salt. Now I want you to look at dichromate here. It's an oxidation of +6. Now when you use it though, let's say down here, I got 3 alcohols plus 1 dichromate, 8 protons from some acid, makes me 3 aldehydes. But look what else it makes. It makes 2 chromium salts +3. I'm assuming whatever acid you use, the anion part would be whatever anion is on your acid, okay? But it's going to be, the point is it's going to be a +3 oxidation state. And look up here, this is a +3 too. My whole point is that any chromium 3 salts that are in solution, you can easily get them out the same way as you did with this chloride salt, okay? Whether it's a sulfate or whatever you're going to have, as long as it's chromium 3, this will work, okay? So let's say I use some of this dichromate, right? You can see the only metal cations that are put in here is chromium and potassium, and that's both from potassium chromate. The whole secret to this success of this is that you only have potassium and sodium metal ions in your crap solution, okay, that you want to recycle, okay? If you have any other metal cations, it could screw things up, okay, and I'll tell you why later. Now think about this after you're done with this reaction, right? Most likely you're going to use some baking soda, sodium bicarbonate, okay, to neutralize any sulfuric acid that's in the reaction over here, like when you're done. Okay, now that cation, the metal cation, is only sodium, so that's no problem. And then usually when they get done, they might have some of this dichromate still in this side of the solution. They want to reduce it down because it's less harmful then. You know, +6 oxidation, nobody likes that. So they might throw some sulfite in there. But again, it would be sodium. So you still only have potassium and chromium in there, okay? Now I want you to look at this. Nice green chromium chloride. And that's what I used in my first video about how to make chromium hydroxide. Now look at this. This is chromium waste, meaning dichromate was used, it was reduced by oxidizing something, and now it's a chromium 3 salt. And there's a bunch of other crap in there, but you can see there's no insoluble stuff. It's just a nice liquid, no solids. So my point is, you just do the same method. You would take some sodium hydroxide, put it into your waste, your chromium waste bucket, and you would have precip, and the precip would be because chromium and hydroxide will get together and they're insoluble and they would precip out. And then you can just go watch this video and it'll show you exactly how to make that. And then the next step would be to go to my video called How to Make Potassium Dichromate, because it tells you how to do that from your starting product is chromium hydroxide. So between those two videos, it'll show you how to recycle. And that's it. You make your potassium dichromate, then you use it again, and you go back to step one. This right here. You throw some sodium hydroxide in, make your chromium hydroxide. Then you go to the video how to make potassium dichromate. You use the dichromate, and again, you recycle it again. It's that simple. It's not any big secret. Now, I still have this stuff here from when I made potassium dichromate. And this is after the crystallizations and then the recrystallizations. So it's mostly it's what was left over. So it's mostly table salt, sodium chloride. But it does have, as you can see, it is a dark color. So it does have some dichromate in there. Some looks black, but it's actually really, really dark red. It's just really concentrated. That's the crap that was left over. Probably has more sodium chloride in it than it has potassium dichromate or the chromic anhydride, the chromic acid or whatever. But this can be used. For one thing, you can use it, I heard you can use it to clean your glassware with because there's so much chromic acid or whatever. Another thing is if you're going to make chromo chloride, you can just recrystallize that out as it is. Just don't use as much table salt to make your chromo chloride. It's already in there. So this would be perfect. Or you can do something like this. Now I want you to look at this salt. This is actually like a 50-50 ratio of salt here. And you'll notice, see how my camera doesn't do it justice. But I want you to look, see how there's pink. That's manganese sulfate, man-2 sulfate. And I think the brownish white is like a maybe ammonium sulfate. I'm not actually sure. I can't remember. But if you notice, I let these dry really slow. And look how there's clumps. See how you got pink here, pink there, pink there. This is all white, yellow, white, yellow. See how it's split up into different areas. Now I could take that out, even though it's a 50-50 ratio, right? Break these chunks off of here or whatever, or get it before it dries, and separate the clumps, and then recrystallize those clumps. You know, I have two piles of clumps, one at pink, one white. Well, my whole point here is that you can do this with the sodium chloride and the dichromate. Let it evaporate real slow, and they will separate into crystals, but they'll be mixed up. They won't be that great. You know what I mean? You have to recrystallize them, but you can see that it really helps. Now I know these just look like globs, but that's because the water all evaporated. This has been sitting there for like a year, but before the water evaporated, and there was still water in there, you could see they were beautiful crystals separated from each other. I mean, you could literally just, you know, hit it with a little hammer there, give it a little tap, and take a crystal off, and it'd be pure as, you know, at least look pure as heck. I would definitely recrystallize it again, but the crystals looked like crystals, you know what I mean? Not globs of round, you know what I mean? They were nice square, nice angles on them. Just to give you an idea of what you can do with this stuff. Not much. I mean, it is very versatile, but what I mean by not much is that you need a lot of it to do anything. And I'm going to give you an example. Now, we started out with a quarter mole. See here, quarter mole of chromium hydroxide. Took it up to a quarter mole of chromate. But when we took it to the dichromate, remember, di means two, chromate means chromate, two chromates. So you need 2 chromates to make 1 dichromate. So the moles went down to half. A half of a quarter is an eighth. So we're already down to an eighth of a mole compared to our quarter mole here. Now we recrystallized it and everything, and we ended up with about a tenth of a mole. Now what can a tenth of a mole do? And a tenth of a mole is about, or actually a tenth of a mole is 29.4 grams, because here's the molar mass of dichromate. So we have a tenth of a mole. Here's the formula. I used vodka or ethanol and acetaldehyde or ethanal as the chemical that we're going to oxidize. You can get 3 alcohols, and you only need 1 dichromate molecule to make 3 acetaldehyde molecules. That sounds good, but that's only 56 milliliters a mole, right? We have a tenth of a mole. So according to the ratio, it's a 1 to 3. So 1/10 means we can make, if we have 1/10 of dichromate, we can make 3/10 of the acetaldehyde. 1 mole, we said, was 56 milliliters of acetaldehyde. 3/10, so we multiply it by 3/10, or 0.3. We can only make 19 milliliters, and you figure with loss, unless you have a micro distillation apparatus, you are going to get a bad yield, you know what I mean? By the time you dry it with some kind of drying agent and filters and stuff like that, and what's stuck that you can't get to come over, this isn't that much. And then if you want to oxidize it to acetic acid or ethanoic acid, now you're going to need you're going to only get half that. You're going to need twice as much dichromate, one to oxidize it to acetaldehyde, and another one to oxidize it to the ethanoic acid. So you're only going to have 8 milliliters. So what I have, I can only make 8 milliliters of either some type of carboxylic acid, or 19 milliliters of some kind of aldehyde, or 19 milliliters of, I could oxidize a secondary alcohol into a ketone. That isn't that much, but you have to think about it that you can recycle this stuff and just use it over and over. If you have a mole, I bought 2 moles of chromium, and I'm thinking that could last me the rest of my life if I recycle it. If I use a tenth of a mole for each, I actually would like to use a quarter mole, but the weight is just, I mean, almost 300 grams per mole. That's ridiculous for a molar mass. But as you can see in the formula also, I wanted you to notice, there's no other cations, no other metal cations. There's only chromium. As long as you only introduce sodium bicarbonate and like sodium sulfite, all sodium cations, you have no problem with this recycling method. I hope somebody learned something from these videos about chromium chemistry, and the cycle and the ligands. If you have any questions or comments, please let me know. I love talking about chemistry, and always remember, science is great.